Okay, we are at chapter 18, temperature. Uh, and let's share the PowerPoint. I hope it's ready. Yeah, I think it is. Temperature. And they give you a little story at the beginning of the chapter about you seeing the power line wires sagging a little bit more than they do. And here they show a sidewalk with concrete panels, and it's buckled. And the it's all related to temperature and the thermal expansion of materials. But this chapter is about temperature in particular. So let's proceed on. Okay, temperature and the zeroth law of thermodynamics. This seems kind of simplistic, but it's a very important part of understanding temperature. We have item A, and it's got a thermocouple uh, on, uh, contacted in contact with it, and it's 22.5 degrees. And separately, we have B with a thermocouple, and it's at 22.5 degrees. The temperatures of A and B are measured to be the same by placing them in thermal contact with a thermometer. That's object C. Now, if you put A and B together, no energy will be exchanged between A and B when they are placed in thermal contact with each other. They're said to be in thermal equilibrium. Um, so if objects A and B are separately in thermal equilibrium with a third object C, then A and B are in thermal equilibrium with each other. There's not going to be any transfer of energy from one to the other. Why is this necessary? Well, our senses don't necessarily um, provide a good measure of temperature. Um, you can on what would seem like uh, a normally comfortable temperature during the summer. When you are outside in the cold and you come into that same temperature, it may feel excessively warm. So it's as if you were to put your hand in a ice bath for a period of time till it starts hurting, and then transfer it to a room temperature water. It could feel very hot. So the sensation of temperature can be very relative. Um, so we need a reliable and reproducible method for measuring relative hotness and coldness. Um, so the uh, the thermometer does that, and so we it a thermometer will measure temperature irrespective of whether what it measured before. It's an objective measure, um, and we know what we're going to learn is that energy transfers from a hot item to a cool item. We think of, well, you have a glass, you just brewed a glass of hot uh, 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 you just brewed some tea, but you want iced tea, and so you put ice in it. So it's not really that the ice cubes are cooling down um, the hot water. It's that the hot water is transferring its energy to the ice cubes and melting the ice cubes. It So energy flows from hot items to cold items. Um, let's see if I um, covered everything. Um, So think of temperature as property that determines whether or not energy will transfer between two objects when in thermal contact. Two objects in thermal equilibrium with each other at the same temperature won't transfer energy. If two objects have different temperatures, not in thermal equilibrium, then the energy will transfer between them when they are placed in thermal contact, and it'll be that the hot item will transfer its energy to the cold item. Um, Okay, let's look at this quick quiz. Two objects with different sizes, masses, and temperatures are placed in thermal contact. In which direction does the energy travel? Well, I've just been giving you that. Energy travels from the larger object to the smaller object. Energy travels from the object with more mass to the one with less mass. energy travels from the object at higher temperature to the object at lower temperature? Well, obviously, from what I've just been saying, it's C. Energy travels from the object at higher temperature to the object at lower temperature. A higher temperature means that the molecules have more kinetic energy. They're moving more. You put it to something that's colder. That kinetic energy transfers to the colder atoms that don't have as much kinetic energy. So it's a transfer of kinetic energy to the colder material. Okay, and that's an introduction. Next, we'll talk about the Celsius temperature scale, thermometers and the Celsius temperature scale.